started using your graphing calculator before it told you to. I believe in number 8 or 9 it said using your matrix capabilities. Number 7 did not say so. Ryan Union, you reminded me that there was a nifty formula, I think somewhere, a nifty formula that we could use. I think you even called it a trick, but I told you it only works for matrices of what size? Yeah. And what size is this one, everybody? It's a 3 by 3, which means it's a square. And since it's a square matrix, could it be invertible? It could be invertible, so I can't just say no solution and move on unless I'm one of those lame-os that says, I try that every time. Instead, you should be actually trying to solve it. Does it say using the matrix capabilities of your grapher? No, so that means there should be a way to do it. Do you remember from yesterday what that way to do it is? If we weren't using a trick, but if we were using one of the other methods, could I multiply it by an ABCDEFGHI matrix and make a big old system of equations with all of those little pieces? Maybe. Is that equal to an identity matrix? But there was a better way. It was called doubly augmenting, although this one might be called triply augmenting. Question, what would you be triply augmenting it with? 7, 3, 3. Actually, you know what? I'm going to do it over here so I don't have to rewrite it. And we're just going to pretend that this guy is like a dotted line. Dot, 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 dot. What am I going to augment it with? The tearing down of one should be the building up of the other. This one starting at its how is that word pronounced? Zenith? This one starting at its maximum capacity, while this one starting at the bare minimum. What's the bare minimum matrix, guys? What's the identity matrix? Reduced row echelon form with ones and zeros, right? And then the appropriate spots. Now what do we got to do? Tear down the one as we build up the other. Tear down the matrix as we build up the inverse. Tear down the original as we build up its undoing. You can make this whole dramatic spiel about it if you want to, but what do we need to do? Sadly, get a leading coefficient of 1. And getting a leading coefficient of 1 is going to start us off with 1/7 R1. This is like the 3rd day in a row, 4th day in a row, class period in a row that I have had to do systems of 3 equations because you guys keep on saying that you can't do them. You can, I just don't think you like to. 1/7 of 7 is 3/7 of 3, 1/7 of 3, 1/7 of 3, 1/7 of 1, 1/7 of 0, 1/7 of 0. Okay, there he goes. Do I have a 1 in the right spot? Yes, I do, but once I have the 1, what do I need to also get? I need to get a 0, and not just 1 0, but I think you said it right and I said it wrong. You need to get multiple zeros, right? Those of you helping each other, that's cool and all, but make it quiet or else I'm just going to put up my volume. As we're trying to get zeros, you guys should be masters at this by now because we need to just multiply whatever has the established 1 by the opposite of and then add. Are we all good on this? If not, ask me now or forever hold your peace. Not forever, but for the rest of class. How do we get zeros? Multiply by the opposite and add to where it needs to go, right? Cool. So I am going to end up getting 1 0 0, but I need to fill in the rest of it where it gets a little messy, and you guys better be thinking of fractions. Hey, what is my denominator that I need to be thinking in? Sevenths. So therefore, couldn't I come up here and couldn't I think of all these guys? Wouldn't 1 be, well, I've already done it for you. Guys, what is 1 in terms of sevenths? 1/7. Nope. Oh, wait. I have 1 whole pie. It was cut into sevenths. How many slices do I have? 7. I have 7 sevenths. 7 sevenths. 7 sevenths. Oh, I have 2 pies, and it was cut into sevenths. How many slices? What? 14. Shout out pie day. 14 over 7. And then that guy's going to be a 7 over 7 and a 7 over 7. That might be helpful when I go to do this step of -2 times and then plus, because as I go into the math, I'm going to have -2 times 3 sevenths is -6 sevenths. Remember, that's a 2 over 1, everybody. -6 over 7 plus 7 over 7. Okay, no big deal because I have sevenths. That's 1/7. And then -6 sevenths plus 7 sevenths is 1/7. No big deal. I got it. -2 sevenths plus 0 is -2 sevenths. And then, well, anything times 0 plus will just stay the same. Anything times 0 plus will just stay the same. Okay. As I go to the last one, the exact same idea in the sense of -6 sevenths plus 7 sevenths. Negative 6 sevenths plus 14 sevenths. 6 and 14, I think that's 8 sevenths. Someone double check me. Negative 2 sevenths plus 0. And then 0 and anything. 0 and anything stays the same. Okay, cool. What do I need now in the second row, everybody? Sorry, in the second column. In the second column, what am I aiming for? My 1, and I always get a 1 by multiplying by its reciprocal. So I'm going to go ahead and just multiply all of those guys by 7. But as I multiply by 7, maybe some of you guys could even just do that now. Because isn't it just going to be a 1 and a 1 and a negative 2 and then a 7, right? Cool. Then I can go ahead and use that row with its established 1 to go ahead and get everything else all nice and canceled out. And so all nice and canceled out will be in row 1. I need negative 3 sevenths times row 2 plus row 1. And then in the bottom row, I need negative 8 sevenths, row 2 plus row 3. Let's go, let's go. Have you found your mistake yet? Did you follow what we did in class so that you even knew how to start? We keep this guy the exact same because he's good. We have 0, we have 1, 1, negative 2, 7, and 0. There he is. And as I multiply, anything times 0 will be 0, plus it stays the same. Negative 3 sevenths times 1 seventh plus 3 sevenths. Yep, that goes away. Negative 3 sevenths plus 3 sevenths. Oh, that's nice. Negative 3 and negative 2, that'd be negative, remember it's over 1, everybody. That'd be, no, positive 6 sevenths. 6 sevenths and 1 seventh, that's nice. Negative 3 sevenths and 7 is negative 3. Negative 3 plus 0 is a negative 3, and anything times 0 will just, will just remain the same. Negative 8 sevenths. What am I multiplying by? Row 2. Negative 8 sevenths times 0. Anything times 0 plus will remain the same. Negative 8 sevenths. I skipped it, didn't I? That should be a negative 1 seventh. Did I go to the column 3 for that multiplication? I think. Getting rid of a 1 seventh, right? Yeah, okay. My bad. So negative 1 seventh plus 1 seventh is a 0. Awesome. Negative 1 seventh times 1. Ooh. I should be looking here. Negative 1 seventh plus 1 seventh. Negative 1 seventh plus 8 sevenths. That'd be 7 sevenths, which is 1. Negative, nope, positive 2 sevenths. Minus 2 sevenths, that's just a 0. I have negative 1 plus 0 is negative 1, and then anything times 0 plus will remain the same. Something felt weird. What felt weird? I'm going back to check my 3 sevenths, and that worked out, that worked out. 6 sevenths plus 1 is 7 sevenths. No, that was right. Hey, guess what happened? Just naturally. What do I already have in my third column so I'm good? I already have my 1, and I already have a 0. What's the only thing I need to do? Get rid of that guy. So I'm going to end up with negative row 3 plus row 2, and I'm done. Negative row 3 plus row 2, and I'm done. Because this guy, I already have him in his final form of 1, 0, 0, and on the other side, I already have his undoing, well, his part of the undoing. Ooh, that looks like 30. I'm so sorry. That's a negative 3 and a 0 that I squished. Negative 3 and a 0. I already have the last one because it's a 0, 0, 1. So I already have his part of the undoing, 0, negative 1, and 1. And all I need is that middle guy. And that middle guy needs a negative this plus that, and 0 is 0. Negative this and that, well, it just stays the same. Negative this and that makes a 0. Boop. Negative this, well, that's just 0. Stays the same. Negative this is a positive 1 and 7 is 8. Negative this is a negative 1 and 0 is, I don't know. I did it fast. Anybody checking? Is that my inverse? How could we check? And how did some of you do it and totally skip the by hand process? How do we do it with our calculator again? After you do what? Got to actually put it in there, right? So we got to make our 3 by 3, then we got to go ahead and put in our nice, they're all positive. Oops, that's not going to work. Oh, I could go faster, but then it lags and then it messes me up. I just can't do the negatives because like the little negative sign on my keypad doesn't, it's a minus and it's very sad. I have to go hit it. You don't care. So if we do this and if we do this, we can go grab the matrix, we can grab the A and we can do what, Ryan, to find the inverse? It's the reciprocal button, but for inverse, for matrices and matrices alone, it is the reciprocal button for numbers, but for matrices and matrices alone, I can hit it and say inverse. Dun 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 dun. Got it. Done. Are we cool? That was the most work-intensive question of all the ones that you asked me, so the rest will get easier, but Ryan, go ahead and go.
So when you're first solving for 1, do you always have to multiply the row by its reciprocal, or can you multiply another row that's the opposite and then add it?
As far as the system goes, multiplying another row and then adding, as soon as you add, you could mess up any of the earlier columns. So I would never want to multiply another row and then add at this step, or else I could start messing up my 1s and 0s that I need to stay established. Technically, if you wanted to, like just as a human, not as like a computer system always multiply by the reciprocal. But as far as a human, at the very first step, if you wanted to do some like elimination type dealios, I guess you could. But once you get in the midst of your system, the way that I do it with multiplying by the reciprocal, multiplying the established, the row with the established 1 by the opposite and adding, is not only getting my appropriate 1s, my appropriate 0s, but it's also preserving what came before. Your step won't always preserve what came before, and so you'll start messing up the form as you're trying to move forward. That kind of makes sense? Yeah. Okay, so let's go ahead and go to number next one, which is 10. And number next one says, hey, there's a formula for a 2x2. And that formula for the 2x2 you would just use. So I'm kind of curious, what's the question number 10? You just use the formula? Check it with your calculator. Well, we're going to use this exact same idea in 11. Let's do number 11 and come back in number 10, because number 11 literally gives you the step-by-step. So let's do 11, come back to 10, because this one reviews the step-by-step. Andy, remember you were like, who's the determinant again? Check it. Number 11 actually gave it to you, as did the notes. But I know that you were like, it always happens with a 1 over. Yes, 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 but that's separate. That's not determinant. That was like this nifty inverse shortcut formula for 2x2s only. And one piece of it, that's what I was saying earlier, one piece of it is that determinant guy. Just that AD minus BC. Like a dot product could be used in all these applications, which we skipped for sake of time. A determinant can be used in lots of different ways for matrices as well. It's a special relationship within a matrix that means a lot if you were taking a class called linear algebra. If you're bored, Google linear algebra and see what majors it's useful for. Okay, coming on back. If you're trying to find your determinant for, I believe this is the matrix, but Ryan, go ahead, bud, what's up?
I was going to say, how come, like, last time, like, we only used, like, the right side of the formula, like, we didn't use, like, the 1 over AD minus BC. Like, when we kind of use it.
Well, remember, we were first of all just thinking that there was a pattern, and then we got to the point where we were like, hey, this pattern almost always continues, but wait, this problem, the pattern isn't there, but wait a minute, it's because the pattern is there, but there's this extra something being multiplied. Then we went back to all the old problems and realized all of those determinants were 1.
Oh, okay.
And 1 over 1 didn't make a difference, so then we were able to kind of find the pattern over here. And it wasn't until we got to 1 that I allowed or put in the notes without a determinant of 1, then you were like, wait, but that's not always how it works. And then we realized the pattern is always there, but there is also this extra component. Is that cool? Yeah. I forgot the minus. AD minus BC. And within there we have a multiplication. And so if you guys were taking A times D, remember, I believe it was Ryan that was double checking. And he was saying, is it always going to be A, B, C, D? And the answer is yes, just because it's first, second, third, fourth, and we go by order of row. We go in order of rows. So the first in the row, second in the row, first in the row, second in the row, etc., etc., etc. But as we're doing AD minus BC, maybe you need to kind of write it out. Remember the other way I said it yesterday was, and it should be in your notes, main minus the opposite. So you would need to go ahead for this first part. I think it was step 1. I just copy and pasted different pieces. You would have your negative 1/4 times your not 7/4, sorry, times your 5/9. A times D, go down that main diagonal, minus go down that opposite diagonal, which would be 7/4 times 8/3. I'll allow you guys to go ahead and do that math. And now as we come down to step number 2, Now that you know the inverse exists, because this determinant PS is not 0, and as soon as it was non-zero, we were able to make this deduction that there is an inverse. It is not singular, it is not forever alone, there actually is an inverse that works for it. Then we said, okay, then let's go, and to let's go, we take whatever we find up here, we do 1 over, and we multiply it by. 1 over is going to be the reciprocal of that dude. Maybe we'll do that in a second. But remember what we do, we swap. We swap the main diagonal, so 5/9 comes up as negative 1/4 comes down. We swap the main, but what do we do to the opposite? Add the negatives, or multiply by a negative. Now, each of these are positive, so then they're both going to become negative, but a better way of thinking about it is probably just make it the opposite. A negative would become a positive would become a negative. Make it the opposite. Swap the main, opposite the opposite. And so all we're missing right now is the determinant. Somebody out there has to have done this math, because all it was a quick multiplication of fractions. Somebody tell me, what'd you get for your determinant of number 11?
173 over 36. And it's giving negative.
And 36 sounds good because I have 12ths right here, I have 36th right here, and I could go ahead and make 12ths into 36 by just doing a quick multiplication of 3 over 3. And if I have negative 5 and I have 56 and 3, be 118.
Negative 170.
Ah, that makes more sense. I was about to get there too. I have 24 and 7. That'd be 8, carry the 2, 168. 168 and 5 would be 173. All of it was negative. There we go. So when I come down here, 1 over, come on, cool kids, 1 over. I could write it, but it would look gross. What's 1 over mean in math? Take the what? What's that word though? 1 over. Don't say the word flip, say this snazzy math word. Reciprocal. There she is. 36 over negative 173, or it just makes the whole thing negative. When they say perform the scalar multiplication, come on, cool kids, vectors. We learned about scalars. Scalars are with dimensions or dimensionless. Does it have 2 or 3D, or is it just a single constant? Well, if nothing else, look at the problem and say, if they say multiply, what are we supposed to be multiplying? Well, we're multiplying a matrix with dimensions, but what are we multiplying that matrix by? A scalar, because it's a single number. So we're taking that single number, scalar, taking that single number, and are we allowed to multiply a single number into a matrix without the crazy cross-downness? Why, yes, indeed we can, because what can we do? Finish it up. You guys should be able to, and you can check it in your calculator by just hitting the inverse button. And so let's go back to this one and say, so how does that formula work with a lot nicer numbers? You guys tell me. The formula for an inverse says 1 over who or what are we going to put there? And what's the snazzy name for that guy? Yeah, and you just wrote notes on that, right? We're going to talk way more about him in section 8.4. The determinant, and how do we find the determinant? Similar to a dot product, but not because it's a, useless box, because it's a minus. Who do we multiply? Main, AD, which is going to be 15, right? Minus the opposite. What's the opposite? Negative 2, which is going to be a plus 2. And then what do I do as far as my pattern? Come on, this is a snazzy one. If this shows up in the test, you should be counting your lucky stars because it's easy to do by hand. Oh, that's right. This is the test with by hand and calculator, 2 separate portions. What's the pattern? No! Swap!
Yeah, you swap.
Swap what?
A and D.
Which means the 5 comes up and the 3 goes down. What do you do to the opposite?
Change the sign.
Make them the opposite. So instead of a positive 2, we have a,
Negative
and instead of a negative 1, we have a
1.
positive 1. And now what do we do?
Now you distribute.
Whoop, 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 whoop. Take the 1/17 to everything, and then your very first answer should be a 5 over 17, and you guys finish. Is that cool?
Yeah.
Awesome. So we have number 7, we have number 10, we have number 11, we have number...
Whoa.
What did we see yesterday? What we saw yesterday, right towards the end of class, is that we can actually, ready? Factor out matrix multiplication. Is your mind being bent yet? Are things starting to get a little swirly? Did you take your cross down and pull it back out?
Oh.
Did you pull your xy's out? You're literally undoing the matrix multiplication. When you undo the matrix multiplication, all you leave or have or are left with are the coefficients. And as you multiply, 18 would be with the x, cross down. 12 would be with the y, 30 would be with the x, 24 would be with the y. Oh my goodness, I just undid matrix multiplication. What? How are they saying I should be able to use an inverse? Oh, cool kids, what did we see yesterday about multiplying a matrix by its inverse? What happens with anything times its inverse? It ends up being 1, but in matrix math, it won't be a 1. What will it be? Well, who is the I? It's going to be 1, 0, 0, 1. It's going to be the identity matrix, right? A 2 by 2. But what's the identity matrix by? Or times anything? Itself. So then the identity matrix, no, how is that going to be legal? That's a 2 by 2, exactly. Over 2, down 2. It's going to work perfectly. You're going to end up with x times y. The question, what should be happening on the other side of the equation? Whatever do I do in math when I multiply on one side? Oh, so I can do this and everything is going to be golden? No! Oh, you missed it last time. Before I wrote down that incorrect thing, I said, and I asked a very important question. I said, is order important? Matrices, does A times B equal B times A?
Yes.
No.
Yes, it does. Yes.
No, not in matrices. Unless it's squared.
Oh. Order matters. Yes. Open up with 3 by 2.
What's the only size matrix this can be multiplied by?
3 by 3. Oh, wait.
It has to have how many down?
2 by
2 by 2. 2 by 3.
It could be a 2 by anything, right? It could be a 2 by anything, but let's say a 2 by 2. E, F, G, H, I, J. Is that legal?
Yes.
Is it legal if I move this over there?
No.
Not only might they not be the same, but they might not even be possible. A times B and B times A. So therefore, as we come back to this, guys, can I necessarily just say, throw them in on either side? No. Matrices do not work like numbers. Matrix multiplication is not what we say commutative. As you get to harder, more advanced mathematical structures, not all the same properties of basic numbers apply, so you have to learn those new properties, gentlemen. So question, how could I go ahead and solve? Does it say using the matrix capabilities of your graphing calculator? No. So therefore, how am I going to find the inverse of this little guy over here, this little guy that I called A? Really? So soon? We literally just did like 2 different problems. Is it gone? How do we find the inverse? A, B, C, D becomes D. I don't know. I really don't like doing that. Swap the main. Sorry, my brain doesn't think like that. Swap the main, opposite the opposite, and what do I have on the outside? 1 over? Got it. Oh, I could have done that. That's just 360. I didn't want to do the other one, but I guess I could have done the other one. How could I have done it? I could do 20 times 24, which would be 480, and I could take away 2 24s, so 480 take away 48, which would be something. 436? I might be wrong.
32.
Oh, I didn't do the other part, though. 432? Oh, thanks. Oh, yeah. 440 and then take away. Anyway, 432. Oh, we can keep going. Hold on. This will be easier. Ryan, you already got it? 432 minus 360, and 432 minus 360 is, something gross. Because I would have 40. Oh, no, 40 and then 32 is just 72, right?
Yes.
I get to 400, and then I do a few more. Okay, so I have 1 over 72 times that. Bleh. Then I have that being multiplied by 7 and 13, right? Let's take that away. And let's take this away. And I'm going to go ahead and be lazy. I'm going to leave that 1 over 72 until the very end because I can. And then I'm going to go ahead and, let's see, when I do matrix multiplication, I have this dude times that dude, and I go across as I go down. So I'm going to have 24 times 7 plus negative 12 times 13. So cross down, 24, 7, negative 12, 13, awesome. And then I don't have a crossover down, so just go to the next row, and negative 30 is going to be multiplied by 7, plus 18 is going to be multiplied by 13. I just need to do that and divide by 72, and I will have my final two answers of what is x and what is y. Dun, 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 dun. Whoosh, finish. Last problem number. Haha, we get to use our calculator. Here we go. Go team. A florist is creating 10 centerpieces. Hey, Mrs. Rondon. For the tables at a wedding reception. She does that sort of thing. Roses cost $2.50 each. Let's call them R. Do you love how creative I'm being? Ta-da! So what are lilies going to be? Nice. And irises. Good. Cost $2 each. P.S. WebAssign does that too. The customer has a budget of, anytime you're doing a word problem, do you remember, this is huge for like everything. Look and find the cell phones, because that's what we do everything on, because cell phones are so cool, because we're always on our cell phones. Back in the old days, your best friend was the person that you talked the most with, that you spent the most time with, that you paid the most attention to. Well, I mean, until like everything was normal and you guys like became adults, and then it's like you barely talk to them ever, and it's like, hi. Now you guys have phones for best friends, and it's really sad. Okay, so coming back, think about it. It's deep, and it's really sad. Okay. Show me who or what you spend the most time with, and it explains who you are and how you act. Oh, coming back, and most of you, it's your phone. A florist is creating 10 centerpieces for health, mental, emotional, spiritual. Fight against it. Okay, here we go. Write a system of linear equations that represents the situation. We want totals. Does anybody see that $300 is a total?
Yes.
Nice. Go find another total. Yeah. We need 12 flowers per arrangement, $300 for the whole shabam. And then do you guys see there's this little like random extra thing? Did we have another word problem very similar where there was like a total and a relationship?
Yes.
Yeah.
The interest.
Yeah, remember? Like, same thing. Same thing. What's the bottom one? Twice as many roses as the number of irises, and twice as many roses. So roses equals twice. Keep reading. Oh no! Why'd you just put a number in there? What's it say? The roses are, this is what it's saying, twice as much as
I plus L.
Oh, there we go. But I act frustrated. You got there. It's okay, right? It's okay. Just keep reading and stop guessing. You have to think about it. Twice as many roses. Okay, so I have double the roses. Roses are double. Double what? Double the irises and lilies. Okay, coming back. Hey, 12 flowers. What plus what plus what has to equal 12 flowers? Like what plus what equaled how much money was taken out of the loan of the zoo that needed the $2 million? Exactly. It's how many R's plus how many L's plus how many I's. That's easy, right? So then, how do I get money? Because money is the $300.
It's the coefficient.
Oh, the price is the coefficient of the, yeah, because you paid $2.50 per rose. You paid $4 per lilies. You paid $2 per irises. The flowers at your wedding, it's partially what you like and partially what you can pay for. All right, so 2.4R plus 4L plus 2I. Is that something you can solve? Okay, pause. Is that something you can make into a matrix? Yes. Definitely, because can't I go ahead and put, Question, did they put it in the same order I put it in? No, because they put, right, they put their 300 second, they put their, what? Go back and read the problem.
10.
Oh, there are 10 centerpieces. Gotta think about it. Does that make sense? 10 centerpieces, 12 per centerpiece. Oh my. But it makes sense though. It makes sense though. So what do we have? We have 1R, 1L, 1I. Okay, that's easy. We have 2.5, 2.5R, 4L, 2I. How'd they get 0? Because you subtract the 2I and you subtract the 2L to get everything on one side. So it'd be R minus 2I minus 2L. Oh, hey, look, we got a matrix. Cool, kids. What do they say you're allowed to do to solve? How do I use my calculator to solve? Well, you guys have multiple options, but they technically tell you what you should use. Question, could you augment this with this and do RREF? Yeah, totally would solve. However, how are they technically having you do it? They're having you just kind of use the idea of, like in any math ever, if I have numbers times variables equal numbers, we do the inverse operation, right? So just showing you matrices are not any different. You just have you have to follow a very specific, ordered method to solve. So how could I do this in my calculator? I would go ahead and, Ryan, do you disagree with anything in the matrix, kid?
I just had a quick question on how you got like the third row. Because wouldn't it be like 0, 0, or sorry.
Well, no, because I just, we need to get all the variables on one side. So I distribute the two, and then I subtract this guy and this guy to go ahead and get my 0.
Yeah, okay.
And as I subtract from one, I subtract from the other, and I make sure to put it in the same order. Does that make sense?
Yeah.
Yeah. But yeah, you're right. I did that very quick. Very quick. Did I just say quack? That's awkward. Okay, so we have 1 and 1 and 1. We have 2.5 and 4 and 2. We have 1 and -2 and those silly negative numbers, -2. Don't we also need to have, though, that other matrix? Because we need to multiply it. The inverse, when I find it, need to multiply it by this dude. So let's go ahead and put in that. Ooh, guys, what's the order of this dude? Yeah, remember, how many rows and then how many columns? I mean, you could check it on your calculator, which is really nice, but it's a 3x1. On the test, you'll have your non-calculator first, so just be careful if you're like, oh, I'll just plug it in my, know your orders. 3x1, and we have 120, 300, and 0. Whoops, 3,000. There are 5 sections. What are we technically doing? We should probably go peek in. Probably shouldn't have been recording that, but you're welcome. We're just doing 4. Because 5 is like a big old application-y thing. But Friday is a minimum day and Monday is a chapel day, so then we're just kind of using both of them for finishing up / getting ready for our test on the normal day, Tuesday.
So the test is still 8.4.
Yes. Yes. Because remember last time I showed you guys dot products, but we didn't go deep into applications. This time, determinants, which is like the main matrix special guy, is its own section, and I'm not going to the application. Is that cool? Ryan.
So that's the part I got confused on. For the last equation where you put R equals to I plus L, I put 2R because I thought it said there's.
You have to think about what it's saying. The number of roses, twice as many roses as the number of irises and lilies combined. So you combine the irises and lilies, you double that, and then you have how many roses? Do you think about the English and what it means in math? So it's not saying the number of irises and lilies are twice as much as the roses. It's saying that the roses are twice as much as the irises and lilies. Does that make sense? So in your brain, you could just think, does this mean I have more roses? Or does this mean I have more irises and lilies? Whichever one it's more of, put the double on the other side.
Yeah. Okay.
But yeah, you're right. I understand how you did the other one, but just be careful. It indicates I have more roses. So at the end of the day, guys, I do have my solution matrix. I do have my A matrix, but I'm not multiplying them both. I'm multiplying the inverse of the one. I'm undoing this guy, because when I undo him, that goes away, and I end up with R and L and I, and on the other side, I will end up with the final answer. So I multiply this one by my B. Oh, that's the wrong button. by my B. Dun 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 dun. 80, 10, and 30. And those of you guys that know football, sadly, I'm pretty sure you're not quite so logical when it comes to flowers. Dun 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 dun. Remember he had that football problem with like the different points? Joey would appreciate that. The rest of you are just kind of like blah. Anyway. Didn't you guys have the football with like the free points and the... Okay, I thought so. Yeah, it was more of a riddle. I mean, this one's a riddle too, but most of you don't want to think about it that way. It'd be a lot easier to probably just solve the system. All right, cool kids, that was the end of homework questions. 13, 12, 11, 10. I just did like all of homework. 8.4, let's go. 8.4, let's go. As I get ready to go, I'm going to go backwards. I'm actually going to start here with the examples because I think mentally this will be a little bit easier for you guys. I'm going to throw in some music. I'm going to solve the determinants. You guys can see if you got them right or not. You can kind of like chill until I finish solving and the timer runs out. Not whichever one comes first, whichever one comes second. Does that sound good? Oh, where'd my Spotify go? It was there. Then it got mad at me. If you guys want to stand, if you want to stretch, if you want to stick your head out in the hallway. Now's a good time. As you relax, as you chill, ponder the question at hand. But I'm not going to get you all back in attention until the timer goes off. It's all good.
That looks like 13.
8.1 vocab for matrices.
If I had to guess it.
No,
13.
Oh, that is a plus.
Yeah, 3 would be that was such a cool one. Oh, yeah, it's a good match. That is cat. That is not true. That is Batman is not nearly as good. It was not. It's you can't. Why is Marvel movies better? Yeah, it's more realistic. Yeah, but Batman it's funny. It doesn't make fun of it. It doesn't make fun of it. It makes fun of it. What are you talking about? You're losing. No, you're losing.
That's what that's.
No, Batman is not.
Excuse me, pardon me, excuse me. Who figured out a definition for singular before I totally get you attention? Who can tell me what singular means?
It's not square. It doesn't have an inverse.
Doesn't have an inverse. Forever alone doesn't have an inverse. Think about your formula 1 over 0 is not going to work. Does that kind of help?
Yes.
All right. What do you notice about what came before the equals in these three different problems? What do you notice about what came before the equals on these three problems? I mean, that one said determinant. That one said DET, and I'm guessing you guys are thinking that means determinant. So if we come over here, and if we want to fill in some different notations, do you guys think the first one might be DET of? Right? But is that the only way? What else do you see that I put behind or before the equals sign? Absolute value. Hey, did absolute value have a certain meaning in vectors? Did absolute value have a certain meaning in vectors? Yes, although we would use double absolute value bars, but what did the double absolute value bars denote in vectors? Magnitude, the how muchness. Interesting. Absolute value with matrices, it's not so much the how muchness, like the order or the size, but it is the determinant. Absolute value is another way of showing determinant. But I will never, from this point on, when talking about a matrix, I will never say absolute value because that is not what it is doing, right? Instead, it's determinant of A. The top one is determinant of A. The second one is determinant of A. And what did I show in the very last one? One last notation. You can also use the previous notation with like an entire matrix. They all mean the same thing. The determinant of A can be shown with DET, can be shown with the upright bars around the matrix name or the upright bars around the matrix itself. Does that make sense? All right, those of you guys on your phones, it is time to put them away because we need to get into this section 8.4, the last section of chapter 8. And quick reminder of this formula, it is the main minus the opposite. However, that is only good when I have what size matrix, which is exactly what I have written right there. That begs the question, what if it gets bigger? Hey, what if it gets smaller? Let's start there. What if it gets smaller? Let's start there. If it gets smaller, it's the nicest ever, because what do you notice about the answer besides the fact that I used the wrong pen? If it's smaller, there's only one entry, and if there's only one entry, well, the determinant is what it is. Help your buddies out. Some of them got a little bit too much of a break, and they haven't woken back up yet. Here we go. A determinant of something smaller is just itself. Gorgeous, golden. Now it's time to go bigger. Gorgeous, golden. Now it's time to go bigger.
So it's just different formulas with different sizes.
Something like that. Or we haven't seen the general formula yet, and all we've seen so far is a trick for 2x2s. So maybe there is an all-encompassing formula, and maybe that all-encompassing formula works for absolutely every size matrix, but we just don't know it yet. But what ends up happening is for a 1x1, it ends up being the same thing, and what ends up happening for a 2x2 is this little formula is nice and great and good. But what is that overarching formula that will work for anybody? It's called expanding by cofactors. How to find a determinant of any square matrix. How to find a determinant of any square matrix. If you guys notice, this one doesn't necessarily say has to be a 3x3 or higher. This one says a 2x2 or greater, which would also mean higher, right? And I wonder if it would work for a 1x1, but we'll see once we get the hang of it. There are some words up above, but what's the most important as far as understanding is twofold. First of all, the actual formula itself, and second of all, figuring out what the pieces mean. You guys know what the A's stand for. So quick review. What do the A's stand for? A, M, N represents what?
Rows times columns.
Close. That's the order. A, M, N stands for what entry? Which entry? The entry that's in what? In what? What does M represent? What does N represent?
Row, column.
In the nth row. Yep. And the nth. Come on, you hear nth all the time. Column. It can work for any letter. In the nth row, in the nth column. So if it's A11, it's the first row, second column. Okay, we don't use TH on everything, but we use it on most everything. First row, first column would be 1, 1. 9, 1 would be the ninth row, first column. 5, 3 would be the fifth row, third column, right? That's what the A is. We know what the A's are. So the A's are the entries. And if you guys notice, do you see how these entries are going across? What are all these entries? They seem to be all the entries in what? A11, A12, A13, A14, A15, all the way up to A1N. It's all the entries in row 1, right? However, check it. This formula gives us row 1, but what do the words give us earlier? You can choose any row. You can choose any column. What would be really, really nice if the entries were zeros? What would a 0 times anything end up making that piece? Nice. So do you think maybe we'll go looking for rows or columns with zeros?
Yes.
We can choose any row, any column. This is just representative of us using, just an example. Oh, you guys don't like Latin, I forgot. Oh, no, that was the algebra. You guys were okay with Latin. An exemplum, for example, using row 1. But you don't have to use row 1. You can just move across any row, any column. Hold on, but that's not the end of it. What's next? Any row, any column, multiplied by, okay, yeah, I get it. It's right next to, so it's multiplied by. But what are those other guys? Multiplied by their respective what? Do you see how they need to match? Do you see that? The entry needs to match the cofactor. The cofactor needs to meet the entry. So whatever you're using is going to relate to whatever cofactor. And you should be asking the question right about now, what are cofactors, right? And we'll get there. But first of all, this entire process is called expanding by cofactors. Does that beg the question, perhaps there's another process? Perhaps. For 2x2s, you already have another process. You have a formula, right? So this would be another way of solving for a 2x2. But once again, we should be asking ourselves the question, okay, we know who the A's are. You just told us any row, any column. We figured out, or we've talked about how zeros could be nice. But who are cofactors? They're easier than they look. Cofactors, they're easier than they look. I'm going to come straight over to what a cofactor is. No cliffhangers, no making you wait. I'm going to come right over here to a cofactor, okay? Because we need to know who he is. We'll work our way backwards. If you want, you can even write the notes in backwards order. Totally fine. Because we just had a formula. The formula needs a cofactor. A cofactor is this. What? A cofactor is found by alternating the signs of, okay, so it's either a plus or a minus determined by wherever it falls in the chart. In the chart? In what chart? Well, let's use this as an example. Let me write it this way. Okay. Why is one a plus and why is the other one a minus? Why is one a plus and the other one a minus? Let's start with the first one. Question. Cofactor 1, 1. What am I looking at? Any matrix, where am I going to be looking?
1, 1.
Hey, in the first row, first column, what are all the signs? And what are the signs always going to be?
Positive.
Yep. But what am I looking at for the next one? What does 3, 2 represent? Where is 3, 2? Where is 3, 2? Third what? Second what? Third row, second. Third row, second. Third row, second. It always follows this pattern. So what is this pattern? Because we need to know the pattern to be able to fill in the appropriate sign, right?
What if it's not in the pattern? Is it impossible?
The pattern is a part of who a cofactor is. So alternating signs of the minors, alternating signs starting with a positive. And how do you alternate? Well, if you always start with a positive, then what's going to be next to it? And then, right? But I'm not just alternating one way, I have to be alternating every way. So question, what's going to be down? A minus, then a plus, then a minus, then a plus. And what's going to be across from the minus? A plus, and then a minus, and then a plus. And what's going to be across from a minus, and a plus, and a... So we can just continue that. Like, that is the definition of alternating. Alternating back and forth by signs. Back and forth and back and forth and back and forth. Okay, so hold on. A cofactor is the appropriate sign depending on the location of what I'm talking about. The cofactor is the appropriate sign of what? Okay, so you should ask the question, what is a minor? Oh, I'm glad you asked. Okay, right? So we have this formula. We're trying to find a determinant. So the formula says I need cofactors. Cofactors say, yes, I'm the plus or minus, the appropriate plus or minus of a minor. And you're like, okay, what's a minor? A minor says, do you guys see how this is minor 1, 1?
Yes.
Do you see how the 1, 1 is circled and the entire first row is ignored and the first column is ignored? What's the minor? Everything else.
Everything except the first row.
0 is A11. The minor is what's left underneath the first row, first column. So let's take this and put this all together. If we were trying to start off with some sort of formula, for instance, if I was trying to get A11 times C11, I would need A11 times the appropriate sign, which would be a positive, of M11. If I wanted, as a part of my formula, A11, C11, I would need to then go ahead and think of A11 times the appropriate sign of M11. And then I could go ahead and plug in everything like A11 is 0, M11 would be, what's around that matrix? Is it vertical bars or is it brackets? What's around that matrix, vertical bars or brackets? And what did we talk about at the beginning of class that vertical bars denote? No, with numbers, yes, but with matrices, what do vertical bars represent? No, what does it represent? Is the whole thing? A determinant. Okay, so if I have vertical bars, I know you think absolute value, but it is not absolute value. Vertical bars mean I need a positive, I'm just bringing that guy out in front, of AD minus BC. But that might be a little bit too much. Let me go ahead and go one more step and let me put my little hey, I'm looking at who's underneath, which is -1 and 2 and 0 and 1. So that would be the same thing as positive 0, A11 times -1 minus 0. Now, as many of you might have noticed at the very beginning, it's just going to be 0, so it's not a big deal. I would not show my work, but that is what the work would look like. And I apologize, it got a little messy right about here. So, let's go find ourselves a determinant of a 3 by 3. And then we'll see if the calculator has a way to double check it. Sound good?
In general, with matrices, what's why do we learn how to do it kind of the calculator can do it for us necessarily?
If you're bored and want some extra exposure to what's going on, Google the class linear algebra and the purpose of linear algebra. That will start to give you an answer. All right, here we go. College professors, college programs are requiring their computer science majors to take an entire class on matrices. That's what you're Googling when you Google why linear algebra. Does that make sense?
Yeah.
And those that are more informed than I am can give a more informed perspective. Is that cool? Oh, okay. I guess we could do that, but I would rather do this. I'll do this, and then we'll go talk about like those weird problems that have you like actually just show your understanding of these new vocab words, but let's use it in context of why we're doing it to begin with. We want to go ahead and find the determinant of A. Don't worry. I'm not expecting you to have totally mastered how to find a determinant. We're just going to go ahead and do it and see if you get some understanding of it as we go along the way. Don't worry. We just wrote down one example. We're going to go ahead and wait. Isn't this the exact same thing of what was just up? 0, 2, 1, 3, negative 1, 2, 4, 0, 1. It's the exact same thing. So check it. If I wanted to use my expanding by cofactors, and if you notice, I am working my way along row 1. So I can totally be saying, if I'm giving explanation, I'm using row 1. I don't have to, but I am. Using row 1, like the formula says. So what I'm trying to find is the determinant of A is equal to A11C11 plus A12C12 plus A13C13. I'm using row 1. That's as big as my matrix goes, so that's where I'm going to stop. And I'm thinking the idea of positive, negative, positive. Since I'm using row 1, I'm thinking of these guys, where I have a positive for him and a negative for him and a positive for him, because those are the 3 signs in row 1 relating to my cofactors. So here we go. I'm going to go ahead and use a positive for my cofactor with a, let me do it this way. I'm going to use a 0 with a positive for my cofactor with the determinant of negative 1, 2, 0, 1. I'll get back to it in just a second. I'm showing you the formula. Then I'm going to go ahead and be doing a minus with the other I'm going to do cofactor 1, 2, which is a minus with the minor, 3, 2, 4, 1. Then I'm doing the last cofactor, which is going to be a positive with the minor. Ooh, can you tell me what's going to go last? Hold on, you're pondering. Don't give it to me yet. You're pondering. I'm throwing in the entries because I need the entries. I use the 0 for the first row, first column. I use the 2 for A12. I use the 1 for A13. Question, what is going to be in that last minor? Because I didn't show it to you. And if you can't see it, follow the pattern. What should be circled? And what should be eliminated? Why are your classmates saying 3? Because that's what's up. Look. Why are your classmates saying 3? Because that's the beginning of what's left. That's the beginning of what's minor to A13. How do we find the determinant? Well, we multiply 0 by, well, forget that. It's just 0. We multiply negative 2 by, hey, what's the determinant, main minus opposite of 3, 2, 4, 1? What's the main? AD. Wait, are we not there yet? I'm sorry. Hold on. I'll pause. 0 times anything is 0, so I was like, forget that. Just make it 0. Sweet. We like zeros. Minus 2 times, hey, it's determinant time. Determinant time, I need AD minus BC. To find AD minus BC, all you do is main minus opposite. So what's the main? What's 3 times 1? 3. Minus 2 times 4. Hey, can we do that in our heads? What's 3 minus 8? Some of you can do that, but if you can't do that, then just think about the math and say, okay, I can write it out in those parentheses. That would be the same thing as 3 take away 8 from my main minus opposite from my determinant, right? AD minus BC, 3 minus 8, got him. I'm not done yet, though. I have one last one, and my one last one says plus 1 times, what's my main? Minus, what's my opposite? No. Multiply. Multiply. Negative 4. 0 minus a negative 4 is going to be positive 4. For anybody looking at these notes later, this might be a little messy, so let me go ahead and write it a little bit nicer. If I'm doing my main minus opposite, I could just squish it like I did the other one over there. It's probably a little bit prettier. So I have my AD minus my BC, which would be the same thing as 3 minus 8. That's where I got my negative 5, and 0 minus negative 4 is where I got my positive 4. And so let's see if we got this right. 0 plus 10 plus 4, 14. Is that my determinant of A? We can check with our calculator, but that would be not near as much fun as me showing you how or why you can do absolutely any single row or column, which we're going to be doing next. Questions in the back. Brendan, start us off. Yes, you may. Sasha.
So because it's 0, we don't bother doing it AD minus BC.
Sorry. I don't know what I just hit. No, go away. Since it's 0, I just thought 0 times anything is 0, so I just saved time. Does that make sense?
Yeah.
Andy.
What?
Oh, Jackson. There was a hand, and Jackson has hand up.
For the formula, does the A and the C like stand for anything specific?
Yes, which is exactly why. Pause and see if you wrote it down. A is the appropriate entry in the mth row nth column, which is exactly what I used first of all with my 0 and my 2 and my 1. So I'm literally filling in my A11, my A12, and my A13. My cofactor is, as we said, the appropriate plus or minus of the minor being the little guy who's left over, his determinant. So that's why I had my cofactor have an appropriate sign, and the minor, the appropriate sign, and the minor, the appropriate sign, and the minor, but be careful, not the minor, but the determinant. Remembering that the minor is a determinant, so I had to go ahead and make that final solving. Well, as Sasha said, I didn't do this one because it was times 0. But this one I did, and this one I did. And we're going to go ahead and do it again and see, like, hey, you literally can choose any row, any column. As soon as someone tells me, we'll practice it one more time, then we'll kind of see if that helps. Because it could be any row, any column. Someone choose a row or choose a column. Please choose one with a 0. We like those. What do you guys want?
Third row.
Third row. Okay. So if we were to use our formula for the third row, we would say the determinant of A would equal, what are my entries in the third row? A what? Third row first. Third row second. Third row third. Is this going to have me go across entirely? Yeah. So this is just an example. What if you were using the third row? Some people that helps, some people it doesn't. Some people just need to do this idea of circle, cross, cross. Where you're going to be using, ready? Well, wait. Cofactors. Cofactors need that whole plus, minus, plus. Oh, wait, that's the first row, though. Hold on. What would the third row be? This would be plus, minus, plus. This would be minus, plus, minus.
Oh, plus, minus.
I'm back to plus, minus, plus. So when I go ahead to solve for my determinant of A, the 3 by 3. I'm going to use my 4, I'm going to use my 0, I'm going to use my 1, and those are my entries of the third row. Does that make sense? I'm going to use my 4, I'm going to use my 0, I'm going to use my 1. My cofactor says multiply by a positive, multiply by a negative, multiply by a positive. So keep it the same, make it the opposite, keep it the same. I mean, the opposite of 0 is not going to be a big deal, but we're just making sure that we understand. But then we need to think of, okay, in our minors, we need to multiply by what's left when we ignore whatever row, whatever entry, whatever row, whatever column we're talking about. Now, I've shown you one of them. What happens with 4 when we ignore his row, his column? Who's left? Uh-oh. Who's left? Boys that are thoroughly distracted. Caleb's trying to help you out. 1. Keep going. No. We'll use the 4 in the front. Ryan Corian, what's next? Noah, what's next? Wyatt, what's next?
2.
Okay, make sure. Don't distract. See, you didn't have the answer ready. 2, 1, negative 1, 2. I'm blaming them, not you. Focus. 2, 1, negative 1, 2. It's whatever's left. Now, if you need to, can you keep drawing things? Yes. But let's see if you can maybe like have a way where you don't have to write this 3 times, because that gets kind of annoying, right? Let's see. I didn't want that one. Let's see if we can do this without writing it 3 times. Okay? What if the 0? Right? If I ignore and if I ignore, what's left?
1, 0, 3.
No!
0, 1, 3.
There you go. 0, 1.
2.
You ignore. What's left? 0, 1, 3, 2. The last one. You ignore. What's left?
0, 2, 3, 1.
Now, how do we actually solve these? Main minus opposite, so 4 minus negative 1, right? How do we solve these? Main minus opposite or 0 minus 2? How do we solve these? Main minus opposite or 0 minus 6? And that needs to get multiplied by what's in front, which is a positive 4, a negative 0, and a positive 1. What's nice, Sasha, I wrote it this time, but what's going to happen? Everybody with the 0 times? We love zeros. We just ignore them. Michelle, you need to go? Yeah. Just sign out. Leave it on your desk. Guys, we go ahead and do main minus opposite. 4 minus a negative 1, that's 5. And 5 and 4 makes 20. Go team. 0 minus 6 is negative 6. Negative 6 plus 1 times 1 is negative 6. Hey guys, what did you just notice about what we just got as our final answer? Guess what's going to happen? Any row, any column that you use. Interesting. A determinant is not bound by a row or by a column. It is an underlying property of any matrix that will be found regardless of the row or column that you use. So you get to choose the one that's nicest to you, and hopefully with practice, you can also then make the most efficient choice as well. Ah. Why is Brendan asking about a 4x4? Doesn't work. Wait a minute. What does this say, though? Doesn't it say any order 2x2? Maybe you should be asking first the question, how do you use it on a 2x2? Well, that's an interesting question. How do you use it on a 2x2? If I was to use it on a 2x2, I would use any row, any column, right? So if I wanted to find this using my cofactors, I would go ahead and use A11. Sure, why not? Let's use the first row. A11, so I'm using 2 and negative 3. What am I multiplying them by? The minors. Ignore. That minor would be 2. Ignore. That minor would be 1. My cofactors would say, that's a positive, that's a negative. What do I end up getting? Guys, what's the determinant of a number? Just itself. 2 times 2 is 4 minus a negative 3. Does it work for 2x2s? Yes. Interesting. Could we kind of make it work for a 1x1? The answer is yes, but why would we need to? Just keep it the same and it's not a big dealio. You could circle it and say, yay, and then there is no minor, and we just, okay, I don't know. Okay, it doesn't really work great for 1x1s because it just is itself, but anything 2x2 or greater. Guys in the back, go ahead. What's up? What's wrong? So the question that was just posed was, as I was trying to show that this process does work for 2x2s, although you guys have a very good process for 2x2s. Main minus opposite is what I would always do for a 2x2, but just showing and reminding that this expanding by cofactors does work for 2x2s, like it's stated. The question was, why are you all of a sudden subtracting? It's not that I'm all of a sudden subtracting, it's that I'm using cofactors which alternate signs, and so I use the alternating sign idea like I used in all my other ones over here as far as alternating the signs as the given row requires. And then the other one, they just happened to like the third row, so it just happened to look the same. But if I was using something like the second row, the signs would be a little bit different. Brendan just asked, what if I have a 4x4? Because he just wants us to level up right now. So, okay, Brendan, here we go. You ready?
Thank you, Brandon.
Hey, question. Why do I have only 2? The first time I did a 3x3, I had little circles. I had little circles, and I had little things crossed out. How is it possible if there are 4 entries in every single row and every single column, why did I only copy and paste the matrices twice? Do you have any idea what column I'm about ready to use? Yep. Anybody know why I'm using column 3? Now, what I said earlier was I love zeros. The dilemma is, as you guys get some practice, you might realize it's not always easiest to choose the row or column with zeros. Wherever the zeros happen, whether it's outside or whether it's inside, whether it's the entry or whether it's in the minor, it's going to help wherever it is. But I'll let you determine as to whether you like choosing the row or column with zeros or whether you like keeping the zeros for the next step and choosing rows or columns with numbers. But in this one, I'm just going to go ahead and say, all right, yeah, sure, zeros. Whisper, whisper, whisper. I'm just going to say, all right, we like zeros, so let's go for it. Most people's intuition would say that. So do you guys notice why I'm going to go ahead and circle, cross, cross, and then circle, cross, cross? Why are there not 4 of them? One more time. So let's go ahead and remind ourselves of what we're doing. What we're doing is the determinant of A. And what the determinant of A requires is all the elements of a row or a column. As you have already deduced, as I have already hinted at, I am going to be using column 3. And using column 3, it would be A11, 12, 13, A13. If you want to see a formula, A23, I'm moving down the column. A33 and A34. I moved down that entire column, right, cool kids? But why am I not putting any work for these two? Because what is A33? I don't care about the cofactor, because whatever the cofactor is would just cancel, right? Because of the entries, I don't need to worry about the last 2. Now, for these entries, I have a 6 and I have a 3, but if you guys notice, like Sasha, you're right, my formula is a plus. But if you realize in the formula, I haven't done the cofactor yet, and the cofactor brings in this idea of alternating signs. Positive, negative, positive. All I need is to start and then go through my row. So that's what I'm thinking. I'm thinking that plus, minus, plus, minus. So I'm going to go ahead, and as I start to do my work, I can say, okay, that guy's going to be a positive with, that guy's going to be a negative with. Except I can make more room because I don't have to worry about the last guys, because they already got canceled out. So I just have the first 2, the positive and the negative. I'm going to have my first term, which is 6 times. I'm going to have my first term, sorry, my next term in the column with a 3. And now I need my minors. My minors say what's left. I'm not sure if Brendan totally had this in his head, but I'm kind of guessing that he might have. He was thinking ahead and saying, but wait a minute, if it gets bigger, is the determinant as easy as it was a second ago? As it gets bigger, can I just do main minus opposite? Oh, I didn't cross off above the row, or above the 3. You used your zeros right away, and now they're not there for what you need to do next. Maybe it was a good choice. Maybe there was a more efficient way of doing it. I don't know. Different people have different preferences. But coming back. 276, 151, 377, 262, 151, 377. Pause. Does the formula application make sense? Does the formula application make sense? Am I still using the terms in the column or the row or the whatever? Yes. Am I still putting the appropriate alternator? Yes. Am I still taking what's left and saying, I need you and I need you? Well, I need your determinant. I need your determinant. Question is what we do next. But Jackson, go ahead.
Is there supposed to be a plus sign in between the C23 and 0 and then the C330? No.
Thank you.
No.
I just didn't rewrite. Yeah.
Okay.
But then 0 times 0 times just.
Yeah.
But yeah, you're like, wait, that multiplies. I know. I'm sorry. I do need both of those. Is that cool?
Yeah.
And then I have pluses everywhere else. And for Saucer's question, I could put a plus here technically, right? But then it's plus and minus, and so I just don't worry about it. But yeah. So ready? What will we have to do next? We have to choose any row, any column, and go again. So my final solution would look a little something like this. I would end up with a 6, and that 6 would be multiplied by a 1 with his minor, which would be 7677, which I could then go ahead and get to be 6 times 49 minus 42. Let's see, hold on, but that would be plus, minus, plus, minus. So I would have a little negative in front of that. And then I would have a plus with a 5, and that 5 would be with his minor, which would be 2637, which would be 6 times 5 is 30, times 14 minus 18. Should probably do some of this math in my head, but I'm just modeling for you what's going on with the mean minus the opposite. Then I would have another minus with a 1 with his minor, which would be 2737. Which would end up being, let's see, 6 times a negative 1 would be a negative 6, and that would be 14 minus 21. And that would get the first part of my formula. Then I would have to go ahead and do the second part of the formula, which would be a minus and a 3 times. I'd have to work along his row, his column, positive, negative, positive, negative. You guys realize I keep on reevaluating my alternators, not going back to the beginning, but from whatever matrix I'm dealing with. That 3 would need his first entry times his minor, 6277. The second entry times his minor, which would use 2, 2, and 3, 7. The third entry times his minor, 2, 6, 3, 7. And then we would go ahead and distribute. A negative 3 times a negative 1 would be plus 3, and we do main minus opposite of 42 minus 14. Wait, pause until I do the last one. Minus 15 times 14 minus 6. And then plus 3 times 14 minus 18. No stress, all we gotta do is put it all together. Bye, cool kids.
I'm so confused. How did you get all these numbers, Steve? I'm so confused.
And you're gonna do it like that times like 2 or 5 and then like
Yeah, well, that's right now.
take forever.
Does anything cancel out? No. I would probably save like the 6 till the end. I just felt bad putting lots of parentheses, and I would save the 3 to the end. That'd probably make it easier. My number's not big.
Steve, on Friday, could I help you to help with anything?
I'm gonna be
I think everyone wants to write.
I'm gonna be helping Mr. Rice with Chick-fil-A. So why don't you just come out there and
Oh my god.
I shouldn't have multiplied. That made sense.
Can you move up like a little bit that way so I can see it?
Oh,
Hey, Ryan.
Guys, can you guys move away from the board, please? So we can see. Thank you.
3 in there made it messy. I did the earlier process, but I did it just real fast for the 151 and the 151.
Why did you do the one?
Well, because I didn't want the 2s and 7s and 6s. I get to choose it. I get to choose whatever I want. I like 1s better. Oh, this math isn't bad. It's negative 7 minus 20. Negative 27 plus 7. Those cancel. Negative 20 and 7. Because the 7s cancel, and negative 20 times 6 is negative 120. And then 40 minus 28 is 12. 12 plus 4 is 40 minus 28. 12. 12 plus 4 is 16. 16 minus 3.
Wait, you have to multiply it by the negative. Okay. So multiply this by this. This by this.
That's what I did. Nice. So the negative 7 and the positive 7? I was being lazy, because the numbers got gross otherwise.
So for test, we have to bring the calculator, the graphic calculator.
For what?
Test.
Well, actually, your syllabus at the beginning of the year, it's been a required thing all year long.
Yeah, but we don't necessarily use it, right?
That was your choice.
Yeah.
So if you want to try to do your scientific calculator, it'll make the test much longer, and you only have the class break.
Okay, so we don't have.
I would
test.
borrow.
Okay, thank you.
Yeah. It would be a very smart idea.
Okay, thank you, Miss
You're
Lee.
welcome.
What is the purpose of this puzzle?
Get them all in the middle.
Oh.
It's a fun one. I like that one. For anybody who's still in the recorder, not that you have to be, but you might be, I am checking to see if I got it right or not.
Do we need a higher level calculator for the quiz?
No, just the one I require all year in my class.
This one count.
If my calculator doesn't have REF,
Then you can do it the hard way and you will not have time. So I would say you borrow a calculator from maybe someone in the next class.
Can I use Google?
No, you can't use a computer for a test. It's been on the syllabus all year long, Baron. You guys have been trying to avoid it.
Yeah, but.
You can try to borrow one from any of the kids in the next class. You can wait and ask. Or if you have any other people in Algebra 2, you can borrow their calculator maybe. Algebra 2 kids have it. Or there are 4 honors pre-calc kids in the next class. I don't think any of them are in here. But that's up to you to do, because you made the choice not to get one, right? So it's up to you to do.
By what?
For people that are still watching the video, I am so sorry. I was getting distracted in here, but I was trying to see if I was right or not while showing how to do a determinant on the calculator. How to do a determinant on the calculator. Second matrix over to math, DET. If you've hung in there this long, you are being rewarded to know how to plug it in. Final answer is negative 168. Dun, 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 dun. Good job, guys. I'm going off the recorder now.